Oh my god, 2025 is the year of Agentic AI, MCP. You've heard all this, right? And you've tried building multi-agent systems, but you ended up, perhaps with an agent that fights with other agents, duplicates work, or perhaps hallucinates back and forth. Perhaps you were shopping around for MCPs, but it still doesn't cut it. And you were still disappointed because you did not get what you want exactly. And that's totally fine because we're still in the early stages, and oftentimes a single agent with a good LM can get the job done. And so don't worry, my friend. In this video, I'm gonna show you how to cut through the hype, because while MCPs does introduce a lot of possibilities for agentic AI, but knowing how to use these complex patterns versus a single agent is what separates successful implementation versus overcomplicated mess. And this is where I'm going to introduce you to Fast Agent. This is the first MCP code native agent that introduces agent orchestration. So in this video, I'm going to demonstrate the common agentic patterns and, more importantly, when to use it and how to use it. So as 2025 shapes up to be the year of agentic AI and MCP, the skills you're going to learn with these patterns as well as how to use it is going to separate you from everyone else, and it's going to give you that competitive unfair advantage. Okay, so before further ado, let's dive in. Hey, by the way, if you're new to my channel, my name is Imtiaz, data scientist turned into agentic architect, and I help you unleash the full potential of your AI agents. Now, in this video, we are going to be diving a little bit deeper into agent stuff. So if you're using Cursor and MCPs, great, but we want to get past just building UIs or to-do apps and now start building agents. Now, the problem with agents for the long term has been all this code, the boilerplate code that could get messy, right? Especially if for someone coming from the non-tech world, they just want to focus on the agent orchestration, perhaps want to chain different agents together. Perhaps they're just curious to know how to use these agentic patterns and code native, right? So you can actually unlock these agent orchestrations. For a long time, that has been the challenge, but Fast Agent had changed the game completely because they're the first ones who came up with the MCP native and also the agent orchestration out of the box. So that is why it's going to unlock a lot of speed for you, my friend. I made a video previously how Fast Agent works, what it is. Just to recap, it's a full MCP native support agent. It has a really simple declarative syntax for workflows. No code or boilerplate, it's just simple syntax. I'll show you how many lines. It's just literally 5 lines of code for each agent. Works with Anthropic and OpenAI LMs. So what are we going to be building today? We're going to be building the chain workflow, which looks like this. It's simple yet powerful. In the chain workflow, one agent is going to fetch the URL and the other agent is going to summarize it and create a social media post. And this is a good use case when you want a clear sequence where the output of one operation becomes the input to the next. Then we're going to explore parallel workflows where you can run multiple agents simultaneously, aggregate or compare results. This is perfect for tasks that can be distributed across multiple agents simultaneously. In this example, we're going to be building a document grading system where a proofreader checks grammar and spelling, a fact checker verifies content accuracy, a style enforcer that evaluates writing style, and the grader that combines all the feedback into one synthesized complete report. So this structure is also called fan out and fan in. We'll explore this detail. We are then going to explore the Evaluator-Optimizer Pattern, or loop until results are excellent. This is actually pretty common in machine learning 2.0, or where you want to do prompt tuning and you want to have agents continuously work on the prompt until it becomes refined, or what I call gold. So you want to turn your data sets into a much more valuable asset for you. Evaluator-Optimizer Pattern. Now, and this could apply to anything where you just want one agent talking to the other agent back and forth. This could go on forever. So one thing we do is keep the number of iterations we put a limit on it. But you have to be careful, because if you do not set these limits, then you will run out of tokens faster than you can say oops. Then the last agent workflow we're going to explore is the router. It picks the best agent based on the prompt. So it looks like this, where it delegates the task to a code expert or a general assistant or URL fetcher. Basically, intelligently routes requests to the most appropriate agent. And in another complete video, we're going to explore the orchestrator, because that is the final boss. It plans complex tasks, delegates subtasks, manages dependencies, and aggregate results. So you don't want to miss that as well. Make sure you like, subscribe, and hit the notification bell to follow this series on Fast Agent. And then I'll make another video on human input workflow, because I believe that you need humans at the end of the day to make the final decision, sign off on the agents, or even intervene when agents are fighting with each other or just not being productive, right? So a lot of tokens could be wasted if you're not careful. Before I dive in, I want to caution you still, you don't always need complex patterns. Sometimes a single well-prompted agent is sufficient. Always start simple and add complexity only when needed. Watch my previous video where I created a basic agent. I had a few MCPs connected to the agent, and it was able to autonomously carry out those tasks without me having to put any of these agentic patterns. It does look cool though, and in some cases it's actually good. So without further ado, let's crack into this video. So to get started, we're going to use Replit. It's a software development environment. If you're not familiar with it, go watch my last video where I give you a simple introduction, a gentle introduction to coding or using the robots office using Replit and fast agents. And there's a lot of code here, but not to be afraid of, my friend, because I'm going to explain what each of these workflows, how they operate, how to really read it, and how to run it using the terminal. You're already talking to the agents. So now to get access to this Replit template absolutely for free, this is going to be available for you. Just click on YouTube and find the video that's relevant and grab the template. Easy peasy, apple squeezy. Let's get started. All right, so first workflow is going to be chaining workflow. It's the chain pattern that we talked about. There's going to be one agent that is going to fetch a URL, and another agent is going to be a social media writing agent. So in order to run this, let's navigate the directory. So we are currently in the home directory. If you look at the shell, this is the workspace directory. However, we need to go one step deeper into the workflow directory to access all these awesome Python files. And these are all the examples of the workflows, right? So what we're going to do, cd into the workflow. That's a common command. Cd is it, we go into a directory, boom. And we are already in the workflow directory. We can type something like ls, and it's going to list out all the files that are in the workflow directory. If you didn't know that, now you know. We're going to start with the chaining.py file. So we are going to go back to a website that we want to scrape. So we are actually going to scrape the Fast Agent GitHub repository. Two birds with one stone. We are actually going to use this as a guide as well to run the Python files. So why not? However, just pay attention to anything you scrape in the World Wide Web. Some websites could have a defense system to block any robots or agents from accessing the files. So you might not be able to do all of them. You just have to, there's other ways to get around it, but for now, we'll just keep it simple. So what we need to do first is copy the uv run agent.py. This is the command we just need to run to basically run the workflows. Go back to Replit, we're going to paste this. And instead of agent.py, we're going to choose one of these files we need to run. Chaining.py is the first workflow. All right, now before we run this, let's also make sure the website here is the GitHub website, because this is the website we're going to scrape. So the chaining.py file is ready for us to work with. Now you can also change the prompt for the social media writer. You can change the prompt for the URL scraper. Okay, these are instructions to the agent, right? We're going to keep it the same, and we're going to go ahead and press enter. and it's autonomously going and chatting with the agent one by one. It is fetching the URL. It's also telling you what it's doing. I'll do one more fetch to get the remaining content. So perhaps it's scrolling through the website and it's making sure it gets every bit of information. So it might have to do it a couple of times until it gets the complete stuff. And then it's once it fetches all that information from GitHub, as you can see, it then goes ahead and starts chatting with the social media writer, and it has completely finished the writing. So let's go check it out. So streamline AI agent development with Fast Agent, a powerful Python framework that lets you create sophisticated multimodal workflows using Anthropic and OpenAI models. So it has finished doing the job. So as you can see, this is an example of a chain workflow. Now let's explore the parallel workflow. This is also going to be an important workflow for you guys to know. This is what I call the fan out and fan in method. It's going to autonomously assign three agents to do certain things and then combine the results to give the final output. All right. So in this example, we're going to build a document grading system where a proofreader checks grammar and spelling, fact checker verifies content accuracy, style enforces writing style, and the grader combines all that into one final report. So this allows multiple analysis or multiple agents to do their analysis concurrently at the same time and combine the results. So as you know, when you have multiple experts working on something, it produces amazing results. And then obviously you need to synthesize and combine all that efforts. So this is exactly how this is set up. We name the agent parallel workflow, and then we assign a prompt for each of the agents, and we also have a name for each of these agents. This is all written in English, so you literally have no excuses to actually start changing this, testing it out yourself. The only thing here is that it's written in the Python language, but don't be going out there and taking Python classes now. That's not what I'm saying. I'm saying, look, here's the agent, go build it. All right. So once you finish doing the agents, you're going to create the workflow. For every workflow, you are basically have name and the settings. So the name here is parallel, and the fan out is going to be branching out, doing the analysis. What agents you want to do the branched out analysis. These are all the experts here, and the fan in is going to be the final synthesized agent that's just going to combine all the efforts into one. This is the grader. And prompts is student short submission short story.txt. Let's go look at the short story.txt file. So you'll notice in the directory we have something called short story.txt. It's a short story. That's a txt file, so it's going to run the analysis on this file. And just like we did with the chaining workflow, we're going to do the same. Press up arrow to access the previous commands, and then you're going to replace the chaining to parallel.py. Let's go run this. It's going to set things up. And also, here's the interesting thing what we did here. Let me go back to the code. We have different models for each of the agents. So this is an example of something what we call compound systems. When you compound the strengths of one LLM with another LLM, is all the LLMs model have strengths and weaknesses, right? So when you compound agents capabilities, you get a really nice output. Great. So you see how fast everything is. So you just saw they do the analysis in real time. Now you can see the output of each of the agents one by one. The fact checker, the style enforcer, the proofreader, and the grader. So the grader gives you an output in the heart of blah. Here's a detailed review of the short story with the corrections and suggestions, grammar, spelling, and punctuations, then punctuation improvement, consistency, tense, narrative style. So as you can see, there's the grammar checker, proofreader, the style enforcer. All of them, there's more depth to the analysis here. And then finally, I believe the final agent was able to also provide suggestions on what to do to make this even better. This is an example of the parallel workflow. Now we're going to investigate the Evaluator-Optimizer workflow. In this example, we're building a cover letter writing system that keeps improving until it reaches excellence. So now One caveat is that tokens and setting up guardrails, right? It can go off indefinitely. And if you let your hands off the steering wheel too much, your tokens are going to keep on increasing, and your credit balance for your AI or APIs is going to go down like the job market, right? So you don't want that to happen to you. Keep control of the steering wheel at all costs. Now, so we have the generator that creates the content, and then we have the evaluator that provides detailed feedback. So now let's see how the code would look like. Let's go pick out the evaluator.py file. And just like we did with the other agent examples, we're going to name it. This is the Fast Agent Evaluator Optimizer application, right? Not necessarily agent, it's the application. And under the application, you have all these agents, right? You have the generator agent. This is the generator. You are a career coach specializing in cover letter writing. You're tasked with generating compelling cover letter, given job posting, company information, tailor the responses to the company and job requirements. We're using HiQ3. So HiQ is one of the low tier models from Claude. So it's going to be token friendly when you're using these things. And then you have evaluator. Evaluate the following response based on the criteria below: clarity, specificity, relevance, tone, persuasiveness. And the model here is GPT-4o. So this is another example of compounding where we use one model to evaluate the other model. So this is going to give you a little bit of agent optimized output. There's a couple of parameters. Just like with any workflows, we have to set up a name. This is a cover letter writer. Then the generator is going to be the generator agent. The evaluator is going to be the evaluator agent. This is going to be the same names you've set up when you've created the agents, right? So evaluator, just the same name. You're just going to tie it back here. And also minimum rating, excellent. Strive for excellence. I'm not even sure if you want to look for anything below excellence, because that's not me. I'm always striving for excellence. By the way, random fact, my name in Arabic means striving for excellence. So I'm kind of stuck with that namesake. But anyways, maximum iterations. Now this is the key part here. This is the amount of times you want evaluator and the generator to talk to each other. If they talk too much, it's a lot of noise, a lot of hallucination, a lot of chaos. You just want to find the right balance of talking until you get the desired output. And you can just tweak these parameters, start from low to high. All right. And then what we're doing is we're setting up variables. If you don't know what variables is, it's kind of like a containers for text. Job posting is a little container. You're just stuffing it with a lot of text. Candidate details is a container. You're just stuffing it with a lot of text. And you could think of this not in the domain of just job posting or anything else. You can think of these containers for any specific domain, right? Instead of job posting, you could do like a social media post, something like that, anything that you want text to be added into that container. So you can change these variables. And the way it's getting used at the end is the agent.coverletterWriter, the workflow, has a send function, and inside the send function, they're just putting in all these little details. And if you know a little bit Python, it does help. All right, this is called string formatting. If you want to get a little bit detailed, so write a cover letter for the following job posting, and this is where it replaces the variables that we have assigned earlier, and we're going to run this. That's literally it. Let's go run the Evaluator-Optimizer 3 times. So .py, it's starting. I actually love seeing how these agents work with each other, because it's really good because it's not a black box anymore. You can literally see each step as it's getting done. All right, so they have finished, and this is great. So you can see that the agent had done a couple of things here. Now I'm not going to go all the way up, but it's basically just talking to each other, evaluating the responses, a couple of rounds here and there. And the final cover letter it came up with is this: Dear hiring manager, I'm excited to apply for the software engineering position at Last Mile AI with my 3 years of experience, avid contributor to open source AI projects. Beyond my technical capabilities, there's a few other things that have been included of team members and other stuff here. Join the mission, people over bits. And then we're going to see the evaluator's evaluation. The cover letter is clear, concise, and well structured, addressing all major aspects required for the role. It effectively incorporates specific details from both. Good. So this is an example of the evaluator optimizer. And I also use it a lot for prompt tuning. And you might also be familiar with this concept. This is machine learning 2.0. And if you're using prompts for voice agents, if you're using prompts for your text agents, you might want to keep on tuning the prompts until it reaches excellence. Then we are going to go to the router workflow. This is the last one we're going to cover today. We'll do another deep dive on the orchestrator workflow, so make sure you subscribe and hit the notification bell to get notified when I drop that. It will require a little bit more in-depth for that. And also we're going to cover human input workflow. So router workflow, it intelligently routes requests to the most appropriate agent. You get a query or maybe a question from the user, and the router determines which agent to send it to, which agent is going to handle this request. So let's go check out the code. We have 3 sample requests. These are going to be passed in the form of a list. This is this syntax you see right here, the square brackets. This signifies it's a list. Inside, you have comma separated lines, and these are each request. So we're going to be testing each of these requests, and we're going to evaluate how the router routes to the appropriate agent for achieving the task. As you can see, if there's any code related questions, boom, code expert. General assistant, boom. Earl Fetcher, fetch the URL. And as you can see, this is particularly useful for voice agents when you're trying to route tasks to one agent who's a specialist, one agent who might be just a generalist, perhaps one agent that handles all the tool calls. So this would be useful for that application. I'm really excited, and I'm using that as well in a lot of my applications where I need queries to be routed to the right MCP server. If you have a lot of MCP servers, you need a way to manage it now, right? So this is going to be very useful, my friend. And this is pretty self-explanatory. You have 3 agents here. One is an agent that does tool calls with a fetch URL, a code expert. You are expert in code analysis and software engineering. When asked about code architecture, we provide thorough practical insights. So it's a coding agent. Now, what they didn't do here, and which you could do essentially, is also specify the model. Because if it's a code related question, I honestly think Sonnet is going to be great with coding stuff, right? So you can actually specify models here, or you could even provide access to certain tools to get knowledge from the coding repositories or something like that, make it more diversified. Well, this is good on its own. The file system MCP server, if you're not familiar, watch the previous video where I talk about what a file system MCP is. File system literally just allows the agent to have access to the directory or all the files in the directory, something like cursor. And the last one is a general assistant. You are a knowledgeable assistant that provides clear, well-reasoned response. Now, for the fast router, this is the workflow, and it's just so amazing how they have this clear distinction between agents and a workflow. Because in a workflow, you just set up these parameters, these guardrails, and it's already done. These are just common patterns. You don't have to write those code yourself. It's just set those parameters. So the name is route. The model is Sonnet. So it's an agent that handles the routing. That's literally it. And the agents, we've specified code expert, general assistant, fetcher. They're going to handle all the subtasks. You can assign anything to happen during the workflow. You can run webhooks. You can create files in your system. You can have the agents run code autonomously. There's so many possibilities you can do, right? But let's just leave it at that. In another video, I'm going to show the extent of how you can push these agents with the data, tools, memory, webhooks, all that. So let's go ahead and run this. UV run router.py, press enter. So it's running. Router workflow, general assistant, code expert. It's going to use the Claude 3.7 Sonnet. It's doing the tool calls. So for each of the requests, we want it to route to a specific agent. So that's how we're going to evaluate if it was able to do the job as explained. So let's go back to the code here and download the summary, download and summarize this. So this needs to go to the fetch agent. So let's see if it was able to do that. So here's the router, and it's basically saying the request explicitly asks to download and summarize content from this file or this URL. The fetcher agent is described as having a tool enabling you to fetch URLs, making it perfectly suited for this task. Boom. So it did a good reasoning, and then now it's going to assign the fetcher agent to do this task. Then you can see the fetcher agent going to do the tool call and fetching the website. Then the next route is the code expert. The request explicitly asks you to analyze the quality of Python code base in the current working directory. This is fundamentally a code analysis task which aligns perfectly with the code expert's agent, with the code agent's expertise in code analysis. So we have a bunch of Python files in this directory, and this agent has access to the directory, so it can pull all these files and do an analysis, which is great. So as you can see, it's using the tool calls, it's using the read file, read multiple files, all these things that come with the file system MCP, and it does an evaluation. The code expert, I'm not going to read all this evaluation, but as you can see, this is done perfectly. Then the general assistant. The request is about key characteristics of effective beekeeping, which is general knowledge topic, not specifically related to code, software engineering, or required URL fetching. So great. So now it routed to the general assistant. Easy peasy apple squeezy. So these patterns implement what researchers call the mixture of experts approach, where specialized models handle different aspects of each task. This creates something called emergent intelligence, where the system as a whole becomes more capable than an individual component. And you could think of it similar to how humans operate in the real world. When specialists come together, you have emergent intelligence. Same thing happens in the agent world. So a single generalist is all right, but multiple specialists combining together to provide the insights is even better. So as LMs continue to improve and also become specialized with specific tasks, like Claude is specialized in code, GBTO is a good generalist, all these kind of things, right? These patterns are going to be more useful. The future isn't about monolithic super agents, but rather intelligent orchestration of specialized components. So when to use multi-agent system? This is the $1,000,000 question, right? You should never start with multi-agent system. If you just want a basic agent, it will get the job done. Watch my first video on the basic agent with fast agent. See, it was easy, autonomous, and pain-free, right? If you're not doing it right, if you're not careful, it might cause a lot of chaos, a lot of noise. So somewhat of understanding of how the system works is going to help you. And that's why I always advocate human agency over AI agency. So without good human agency, you're going to create even more chaos to the World Wide Web. So that's why I also encourage you to join the community, partner with like-minded individuals, spread your message, spread your essence, and connect with the right people to achieve your mission as well. So agency doesn't happen in day one. You must work on it. And so the least you can do is be a little bit proactive, move from the chatbot stage to the assistant stage, because in the assistant stage, you are basically useful because you very well know the true power lies within you. So don't follow the hype. Start with single agents. Start understanding and building your first agent. Don't work backwards. If anything, take the 5-day AI agent challenge to get up to speed, unlock bonuses and prizes, so you can fast track your journey in building agents. So avoid complexity for simpler tasks. If a single agent plus tool call can do the job, don't over architect for fun or over engineer. You see a lot of agents building agent stuff going on in YouTube. Token cost and latency adds up. All right. Yes. So hopefully this gives you a balanced perspective. So as you can see, Fast Agent unlocks a lot of multi-agent capabilities out of the box without a lot of coding, boilerplate, and all that kind of stuff. And code native agents unlock a lot of capabilities that you're not going to get in no code black box chatbots. But if you're really serious about accelerating your journey, join the academy. And also, I'm gonna give away my free book, The Honey, I Think I'm a Robot, and it outlines this time in history that we are witnessing. And as we come closer to the end of generative AI 1.0, we're embracing the dawn of generative AI 2.0, augmented intelligence, where intelligence empowers humans rather than replace them. So we're moving away from automation to augmentation. So if you want to join us in the journey, make sure you subscribe and hit that notification bell and follow us for more updates. All right. So again, if you're ready, drop the silly chatbots and unleash the full potential of your AI agents.